Alright, and problem number one, what do we know about standard deviation? It's positive. I guess it could be 0 if you wanted it to be, if all of the numbers were the same. It is not resistant to outliers, which means that if I throw in a number that's a billion bigger than everything else, and it is the typical distance, or I should say average distance, away from the mean. And that's basically, it's a measure of spread. Alright, in problem number two, we double everyone's salary. When we double everyone's salary, the mean doubles, the standard deviation doubles, IQR doubles. Basically anything that happens doubles. That only happens when we multiply. If we added, then the mean changes, but the standard deviation would stay the same, and the IQR would stay the same. For adding. In problem number three, when we're comparing this distribution, actresses have ages that are a larger range than actors. The median is higher for actors. Both distributions look as though that they are skewed to the right. Alright, for problem number four, we are trying to find the mean and the standard deviation. If we do y equals 1 over 60x, so we're going to do 15 divided by 60, which is 0.25. And then we're also going to do 12.3 divided by 60, which is 0.205. For problem number five, if I'm drawing a distribution where the mean is higher than the median, the mean gets pulled by the tail. So that would be the mean. That would be the median. You're looking for something that is skewed to the right. Problem number six, we need to find out what the z-score is for the 23rd percentile. So I'm going to do inverse norm of 0.23 with a mean of 0 and a standard deviation of 1, which gives me a negative 0.739. Problem number seven, the weight of adult male Labrador retrievers are just normally distributed with a mean of 87 and a standard deviation of 8. So here's 87. Within one standard deviation, we got 87 minus 8, which is 79. 87 plus 8, which is 95. And that is 68%. Then we go down 8 and up 8. That's 95%. And then we subtract another 8, which is 63. 111, which is 99.7%. Alright, you want to select one truck owner. What is the probability that he has a Ford or four-wheel drive? So 45 of them have Fords, 80 of them have four-wheel drives, and 28 of them have both, which gives us a total of 97 out of the 125 people. For problem number 9, you can randomly select one truck over. What is the probability that he owns a Chevy given that he doesn't have four-wheel drive? Well, 45 cars don't have four-wheel drive, and of them, how many of them are Chevys? 18. Now for number 10, we're still using the same table. So we want owner owns a Ford and owner drives a truck. Owner has four-wheel drive to be independent. So first I'm going to do Ford, which is 45 out of 125, and has four-wheel drive is 80 out of 125, and multiply those together, and when we get that, we should get the intersection of the two, which is how many people own a Chevy and four-wheel drive, which is 32 out of 125. So this one is 0.2304, and this other one is 32 out of 125 is 0.256, which are not equal, so it's not independent. But because none of the answers are 0, that means it is also not mutually exclusive. So we're going to stop this video after this one, and then we'll go on to the next 10 in the next video.